If this isn't overexposed, for today I have to determine the wiring. So I almost can make a combo where I use, well, I guess first off I could just use that panel. So I could use the donor machines panel, swap that in, but then I won't have the lock style plug. And I just checked my arc welder, at least the IGBT solid state welder is the 3 plug, the is it L630 NEMA? I forget exactly, but it's the 3 plug style, 3 prong style lock. Anyways, though, my thought is I could take that 240 or 220, I don't know what they call it, 240, 220 outlets and then replace one of these 120s. So the way this is designed, they're using for each outlet an individual breaker. And then for this, the 240, there's an individual breaker on each of the 120 lines. So, I don't know, it just seems to me with the capabilities for the 120, individually, at least the individual outlet, I could run it, say, up to 25, 30 amps. So have, with this style plug, I could use the 125 volt AC plug also. So it seems logical just to put a 25 amp breaker in. I don't know why I need a 30, maybe for surging. And then with this other, even though, like now, the way they're designed, they're in parallel, so the 120 outlet can take the most current. Seems just replaced with a 240, 220, whatever it's called, from the other, and then just have the breaker on there that's like the 20 amp. And then same goes with each leg on the 240, leave that at 20 amp. So then I don't have to worry about frying the stator, and that's about right too, where the current's rated 20.8 for 240 and 40.7 for the 120. Like I said, I probably could go higher than 30, but I have 30, I have 25, and I have 20. I think I have like a 16, 13. I have a smaller size too. It's kind of odd. I think that was with the Predator. So I'm also going to double check with the Predator. Let's pause this and then I'll go to that. And then I also want to discuss possibly custom, adding some of the generic options where basically put a rectifier in, have an hour meter on, and then also have a 12 volt outlet option on here. But we go ahead, pause, and yeah. Okay, like I was thinking, these have already been swapped out with 20 amp breakers. So technically with this design's different, where this 240 can handle the higher currents, where the individual 120 cannot. So originally you can see there's 13 amp breakers, so that was the other number. I knew it was something different. 13 is what it was. So basically I should pull these 20 amp breakers out and then replace with the 13 amp that were originally present. I might do the math and might be able to bump those up a little bit, but I don't think so because this is continuous 3200 watts and a max 4000. Now the Champion design, from what I can see, is different, where it is designed to handle or is wired at least, and I have to read a little more about the designs because there's synchronous, asynchronous, and auto voltage regulation. I don't really clearly understand the differences and intricate details exactly, but I know that Champion generator has a similar rating, but it's designed though and wired, or the design is, to say, for the higher current 120. So I'm going to go ahead and pause, and I'm glad I checked this because I think I'm going to swap these out. Okay, looking back at the generic, so this is the hour meter. Here's a control panel. I mean, I almost could swap out, and it's interesting to see what's here, but that's a L530, so technically it's not rated. It's not for the 220 outlet, which the one welder is. But these also have breakers that I could use. But I guess let's first get back to the hour meter if I want to use. That's a 12, 24 volt DC, so that's what I recall it being. So the 10 amp rectifier, and then could also wire in the 12 volt battery charger. I don't know what that outlet's like, but anyways, that's an option. And then let's see if there's ratings on these breakers. So if we can see so well, 30 amps. So 125, yeah, 30 amp, 240. That one doesn't really show. 250 volt AC, 32 volt DC. That doesn't quite say, it might be on the body somewhere rated. But there's some other options, at least, utilize this panel. Maybe not super critical, but yeah, more options. So I'm going to go ahead and pause. I'm going to show you what the wiring options are that I found that are a good reference to share. So here's what I found doing a little research online. I couldn't find really much information for these Coleman Powermate or Powermate, formerly Coleman, generators. There really wasn't a lot available, so I kind of just had to logically look at what's here. However, I did find this page. Let's see, here it is. Here's a link. So it's Utter Power, and I think he did a really good job explaining. And he's confident these are a synchronous design, not asynchronous. And there's not an AVR, obviously. So this is, if I understand correctly, it's a true single phase 120 and 240. So not like a two-phase design. That's different. So there is a little bit difference in wiring. Like there's not the 5th plug. I've seen that in some images. There's only the 4 for the windings. And I'll verify where mine's not going to be. The green one when I received was already, I could tell it had already been messed with in the box, and wiring had been changed to see if that worked. And I think I was told, I think he reported to me too, he tried working, he thought maybe an outlets burnt out or something, but or the breakers, and just kind of left it as is. I'll be able to verify at least seeing one as a 120 and one as a 240 with this parts machine to see how it's wired. And I'll update that in the next video. I do see a difference here where there's 2 yellow and then there's a blue wire also. So coming from that coil, that's coil in the design, but maybe the blue is like a ground or something. I don't really. I have to think about that. I don't really know. I'll have to look a little bit more reviews. I haven't really reviewed the electrical in this really well. But this article does a good job detailing. And what I like about it is he kind of does like what Honda does. And he specifically talks about. So it's exactly what I was thinking about and researching prior that I do recall clearly because I thought it was really interesting and wondered with these different current ratings and breaker designs. Like one of the things, I wouldn't use 120 amp breaker. I'd wire in, like I said, how they're designed already with a breaker for each outlet and then a breaker for each leg of the 240 outlet. Now he does go into a little bit more detail later here, and he's showing about the windings and how, they're basically wired in parallel versus serial. Well, it wouldn't be in serial, wired parallel versus individually. So if you wired individually, there'd be a difference in that would be similar to the 240 outlet where you'd have the 20 amp limit. But in parallel, you have that 40 amp limit. And he also shows, and this is where I wanted to say about the Honda, is, if you have that higher current rated double pole, double throw switch, you can literally switch those outlets to be series or parallel. So then it would make more sense using those 20 amp breakers on the individual outlets, individual 120 legs. Switching to series, then you'd have to, I have to think about this. Consider how those 20 amp breakers are wired. Oh, I think so. It'd be that they'd be in parallel, so they wouldn't trip unless 40 amps was over 40 amps was present. So, and there's more of this article that goes into detailing where people had questions, and there's a lot of information in the comments. But what's kind of back to this original design, like I was saying with the breakers, I found the Briggs & Stratton 5,000 watts, and this is pretty close. I think this is really right there. The only design difference is this is using an AVR. So is my mouse going to show up? Yes, there we go. So this is an AVR. This is an asynchronous generator design. And this has 2 sense currents coming off the coil. So it's sensing the currents, which is similar to the generic, where there's a coil sensing the load, but instead of being used for the AVR, it's being used for the idle control. So really, this isn't what I'd use, but when you come out to this section here, how there's the fuses are wired into the individual. Now the difference is here, this isn't showing the fuses for some reason in this drawing. I don't understand. Like, they made a separate drawing that I guess is more accurate for what's wired in, because this isn't really accurate, other than here. So for the whole system, there's a 25 amp fuse. And maybe I'm wrong. And this is for 2 legs, so technically you'd have like 2 25 amp fuses. And then after that, so 20 amp fuses. So I guess this is actually, this drawing's correct. This is correct. It's just not this is a correct drawing. So this would be, I think, more accurate and representative of what at least this section here. So let's scroll over. Other than the ground line, this is showing a ground line coming from the generator, from the alternator. So this, I think, is closer. So here's this fuse. You can see each leg of the 120. Let me think about this, because actually this is more representative of the fuse design minus the, this is wired, so the lower current 120 outlets, higher current 240, where I want to in parallel have higher current 120. So this isn't wired the same, other than representing how the fuse wiring is. I should have explained this. I probably should upload this video. But this will be good and embarrassing to make sure that I go through and draw out in detail basically what is shown in this previous design here. Adding the fuses. So there's more fuses designed, and not factoring a switch yet until I get a drawing that's specific. Yeah, so here you'd want, well, technically here you're just saying everything's 20 amp. And, I have to think about this to wire in higher current fuses for these legs, because they're running the positives off the 240 first. Yeah, accent's going over. So you'd want to run these lines into the 120 first, have the 20 amps coming off the 120, and yeah, I'll rewire this. The 20 amps going into the, actually off, like you could have this could be the higher, you'd have the higher current coming off into the 120, and then off the 120 going into the 240, in between you'd have the 20 amp. So there's going to be, I'm just going to have to draw this up. And I'll draw it up based on what I also find from the, yeah, this is similarly designed also, where I'd run to the 120 first to get the higher current breaker option. In parallel, like in the previous design, I'd want to run it in parallel, run them in parallel. And then go off and have the separate lower current breaker legs. Okay, anyway, 16 minutes and a lot of info. Let's see, what was the other? There's another drawing that I found, and this was for that title there. And yeah, this added the hour meter, but I need to have a rectifier to use that Generac one. And these blacks are the whites. That's just one white, and then one ground, where the ground might come off one of the whites, but it's not really the same. So let me see, neutral floating, I'd have to make sure I consider. Yeah, this design, yeah, they're running off the, this is like a parallel, that single white, though they're not junctioning the whites early on. Well, I mean, they are off the 240. Yeah, this wiring wouldn't be the what I'd want for the higher current 120 outlets and the lower current 240. So, okay, anyway, so that's a lot of information. Probably really confusing, but this is at least summarizing for me in the future, so I can, one, look like an idiot, like I don't know what I'm talking about, or I do know what I'm talking about and really starting to catch on to how these operate. I don't see any reason to try to modify. I don't think it'd be right. I really want to understand, what, can I add an AVR off the shelf, or do I need to custom make an AVR? Or is that just something I don't want to think about? So I'm going to first probably wire as is, and then see how the function is, frequency, voltage wise. And if the voltage is a lot more swing, has a lot more swing based on loading, then I'll wonder if maybe I should read into and research more about what options would be available with an AVR, but basically putting sense lines into these, which would only measure current though. I have to think about, to measure voltage off the line, so then adjust the rotor's voltage so that those windings would magnetize differently. I think that's correct. Okay. Anyways, be safe, take care, and keep Christ with you. Make sure to read and learn something new.